Hi, my name is Ada Keener, and I'm back with another homework video. So let's get into it. Problem 1 says, a used car dealership collected data on the selling prices of cars and their ages in years. Based on a sample of cars of the same model, the least squares regression line for predicting price in dollars from age in years is price equals 18,500 minus 1,250 times age. Part 1 of the question says, what does the slope of this line say about the relationship between price and the age of the car? So, looking at the least squares regression equation, your slope is going to be the number that is being subtracted, or in some cases added. So the fact that this number is being subtracted says that the slope is negative, which means that there is a negative association between price and the age of the car. Part 2 of this question says, what is the predicted price when the age of the car is 0 years? How would you interpret this value? So again, using that equation, you can put 0 years into the age of the car, and equating that, you would get 18,500, because this is interpreted as having lost no value because the car hasn't aged at all. Now, if you go to part 3 and you are using the age of 5 years passed on a car, you will plug that in the same way, but you will get 12,250. This is because each year that the car ages, you're losing $1,250. Now, part 4 asks, would it make sense to use this model to predict the price of a car that is 25 years old? Why or why not? It would not make sense to predict a price of a car that is 25 years old, because after 25 years, the price that would be predicted would be negative, because you are losing $1,250 every year, and a car can't have a negative value, so it wouldn't make sense to use this to predict that price. Moving on to problem 2. This problem says fuel consumption Y of a car was recorded at various speeds X. Fuel consumption is measured in miles per gallon and speed is measured in miles per hour. Software output gives the least squares regression line as Y equals 70.243 minus 0.329 times X. The observed data and residuals are shown in the table below. Here's that table. And using that table, part 1 of the question asks us to make a scatter plot of the observations and draw the regression line. So I have already done so here, and that regression line is going through the middle of those. There is a little bit of a deviation from that regression line, but it's not a crazy outlier like we will see later in the question. So using this scatter plot that I've created, part 2 says, would you use the regression line to predict Y from X, and explain? I said I would not use the regression line to predict Y from X because the relationship between X and Y are not truly linear, if you include the point that I have stated is a little bit deviant from the regression line. So if this line was closer to the trend of the regression line, it would be more of a linear relationship, so that wouldn't be a problem. But also, another reason that I wouldn't use the regression line stems from part 4 of the question that I can get into in just a minute. But using the residuals graph that part 4 asks us to create, and checking those residuals first, X equals 20, the residual is negative 14.67, and the sum of all of the residuals is 0, so that is verified. So we can check that off. But using this plot that I have created, there is a major outlier, as well as one that is really similar to the one in the first part of the question. But because of that outlier and the rest of the graph, there is a very similar pattern to this regression of these residuals compared to the one in this graph of x and y. And because the graph of the residuals is not random, that is not what we would look for in a residual plot, because using plots like this, you look for a linear regression in the x and y values, but you are hoping to find a randomized residual point so that it means that they're not completely following a pattern. So part 4 asks, make a plot of the residuals against values of x, draw a horizontal line at 0, and how does the pattern of the residuals compare with the pattern? So like I said, the pattern is very similar if you look at the two. There is that large outlier that's a lot farther deviant from the regression line and from the line of 0 at the height of 0 that you had to create. But they resemble the same pattern. So I believe that answers that question, as well as another reason why I would not use the regression equation to answer for the prediction of y and x. Problem 3 says, a company retains a psychologist to assess whether job applicants are suited for assembly line work. The psychologist classifies applicants as one of A, well-suited, B, marginal, or C, not suited. The company is concerned about the event D, that an employee leaves the company within a year of being hired. Data on all people hired in the past 5 years gives these probabilities. And those are listed right there. Problem 1 says, sketch a Venn diagram of the events A, B, C, and D, and mark on your diagram the probabilities of all combinations of psychological assessment and leaving or not within a year. So, just for time's sake, I went ahead and drew this, but I can explain it. So, events A, B, and C are independent of each other. They are not joined together. So, drawing those, if they would have been looped like that, that would not be a correct representation of these, because if an applicant is well suited, they can't be not suited, if that makes sense. So D has a factor in all of these, or I guess all of these have a factor in D, because D is asking how many of each group will leave within a year or not. So that next question asked just that. What is probability of D, the probability that an employee leaves within a year? So to find the probability of D, you would just add all of the probabilities of each of these groups that overlap into D. So the probability of being well suited and leaving within a year is 0.1. The probability of being a marginal employee and being leaving within a year is also 0.1. And the probability of being not suited for the job and leaving within a year is 0.2. So to find the total probability of all of those leaving within a year, you would just add all of them. And when you do so, you get 0.4 or 40%. So there is a 0.4 probability that an employee leaves within a year. Now on to the last question. Problem 4 asks, a striking trend in higher education is that more women than men reach each level of attainment. The National Center for Education Statistics, which classifies all subjects as male or female, provides projections for the number of degrees earned, classified by level and by the sex of the degree recipient. Here are the projected number of earned degrees in thousands in the United States for the 2027-2028 year. And this is in this table right here. So part 1 asks if you choose a degree recipient at random. What is the probability that the person you choose is a man? So if you're looking for any of the degrees, you will look for the total amount of degrees, which would be 3,990. So that's going to be your dividing factor right here. But it's asking specifically for the probability that you choose a man. So looking at all of these, you're going to look for the probability of any of these being a male. So that's going to be this number right here, 1,657. So you just divide those two right here, and you get 0.415 or 41.5%. So that is the probability for choosing a man for any degree level. Part 2 says, what is the conditional probability that you choose a man given that the person chosen received a master's degree? So, to find the probability of A given B, you have to find the probability of A and B and divide that by the total probability of B. So doing so, my probability of A is going to be finding a male. So then you have to multiply the probability of being a male by the probability of receiving a master's. And using the table, you don't even have to multiply. You can just go and find the intersection. So that first number is going to be 340 because that is the total amount of males that received a master's. And then you just have to divide that by the total number of master's degrees between both genders. So that would be 813, and when you divide those two, you get 0.418 or 41.8%. Now, part 3 of this problem says, are the events choose a man and choose a master's degree recipient independent? How do you know? So what I've written is, the events choose a man and choose a master's degree recipient are not independent. So they are dependent, because in this case, the probability of being a man has an effect on the probability of being a master's degree recipient. You can check this by multiplying the probability of A, which would be the total amount of males, by the probability of receiving a master's degree, and those don't add up to be the probability of A given B. So that would be that number. So the fact that they don't equal the same means that they are dependent. Also, just looking at this, the probability of a total master's is going to be more than the probability of males receiving a master's, because that is a factor in how many people received a master's. So that answers that question, and that is it. Thank you.